Section 8.2, we're going to look at creating confidence intervals for population proportions. All right, so the process that we're going to do is we're going to create a one sample Z interval for a population proportion. All right, and so this formula is how we get our interval. We're going to do p hat, our sample proportion, plus or minus some margin of error. And this formula is our formula for margin of error. All right. To be able to use this formula, there are three conditions that have to be met. Okay. And you can think of it as one for each section of the formula. All right. The first one is our sample has to be random. Okay. So we have to take a random sample. We have to meet the large counts condition that we talked about last time to make sure that we can use a normal distribution. So this Z star value that I'm going to tell you how to find in just a minute, that is contingent on being able to use a normal distribution, which means we have to meet the large counts condition. So n times p and n times 1 minus p both have to be greater than or equal to 10. All right. You'll see that it has p hat in the formula. That's because we don't actually know p. We're using p hat to come up with an estimate for p. And so that's why it's p hat in the formula there. And then the last part is something else that we've talked about before, which is the 10% condition. Okay, so our sample needs to be less than 10% of the population because pretty much every time we're going to be sampling without replacement. All right, so this piece of this formula should look familiar to you, okay? Everything that is under that square root formula, that looks very familiar, looks very similar to the equation for the standard deviation of a sampling distribution. All right, when we're doing it with sample data to estimate, it is called a standard error, okay? So if you are asked to calculate the standard error, that's that part that's under the square root. All right, so let's look at an example. We want a confidence interval for P, which is the true proportion of red beads in a container, which has over 3,000 beads. And we have a sample of 251 beads that had 107 red ones. So first thing we need to do is check if our conditions are met. So was the sample random? Yes, the class took a random sample. All right, did we meet the 10% condition? Yes, the sample of 251 is less than 10% of the population, which is 3,000. And then our last condition is large counts. So n times p is 107, n times 1 minus p is also 107. So we're good to go there because both of those numbers are greater than 10. All right, so you will see that Z star in the formula. That's also called the critical value. All right, that is dependent on the confidence level. So to show you where it comes from, if I want a 95% confidence interval, I want this area here to be 95%, which means the leftover area I have is 5%, and each tail would be equal to 0.025 because that would be 2.5%, which is half of 5. Okay, you can use table A, but we haven't really used table A. It's the more old school method. I would go with the technology. And so since we want an area of 0.025, we're going to use that inverse norm. It's going to give you a negative z-score because we're to the left of the mean, but we are, for z star, we're always going to use the absolute value of that. So our z star would be 1.96. Do you need to draw this curve every time for every problem? No. It's more just making sure you understand where this number is coming from. So for z star, we're going to do 100 minus our confidence interval and then divide that by 2. That's the area that we want. And we can leave the mean as 0 and standard deviation as 1 always. All right, so let's look at an example. We have a sample where 73% of American adults have read a book in the last 12 months, a random sample of 1,520 American adults. This case, the problem says assume the conditions for inference are met. So that means we don't have to check them. If you see that sentence, you're good. Go ahead and start doing the math. But if you don't see that sentence, you should always, always, always check the conditions and write down some evidence that you have checked the conditions. But since it tells us that our conditions are met, we can go ahead and start doing the math. So we need to determine the critical value, or Z star, for a 90% confidence interval. All right, so we are going to use our calculator to do inverse norm with an area of 0.05. 100 minus 90 is 10. 10 divided by 2 is 5, 5%, so 0.05. And then your mean and standard deviation are always going to be 0 and 1. You should get negative 1.645 in your calculator there, and so we're going to use the absolute value of that, so positive 1.645. Then we're going to construct a 90% confidence interval, so we're going to use that formula. All right, p hat is 0.73, that's what the sample got, plus or minus my Z star value times the standard error. So p times 1 minus p, or excuse me, p hat times 1 minus p hat divided by your sample size, take the square root. Okay, so if we do all of that math, you should get a margin of error of 0.019. Subtract that from 0.73 and add that to 0.73 to get your confidence interval. And then the last step is going to be interpret, and so it's that sentence that we learned in 8.1. We are 90% confident that the interval from, and the one we found was 0.711 to 0.749, captures the true proportion of American adults who have read a book in the previous 12 months. All right, so we have this 4-step process: state, plan, do, conclude. All right, SPDC. We're going to do this over and over and over again, not just in this chapter, but in ones going forward. So get used to it, okay? SPDC, that's going to assure that, number 1, we don't make any silly mistakes, and number 2, that we get full credit on free response questions on the AP exam. So the example we're going to look at, I'm going to let you read it, but basically our task here is to construct and interpret a 95% confidence interval. So we're going to do all the steps in our SPDC. All right, so step 1 is state. What are we finding? We're finding a 95% confidence interval for, and then we're going to define the parameter that we are using for P equals, and it's the true proportion of all cell phone users who would admit to walking into someone or something while talking on their cell phone. Okay, so state, second step is plan. All right, what are we constructing? We're doing a 1 sample Z interval, and have we met the conditions? So is it random? Have we met the 10% condition? Have we met the large counts condition? All right, so plan, you're going to say what specific thing you are calculating, and then have you met the conditions to actually do that calculation. All right, state, plan, do the math. All right, plug everything into the formula and get your confidence interval. And then the last step is conclude. And so in this case, our conclusion is just our interpretation with that interpretation sentence. Sometimes the conclude part might be a little bit different. They might ask you if we have convincing evidence for something, and that would go in your conclude step. Okay, so construct and interpret. We got to do the whole thing, SPDC, to ensure that we get full credit on the AP exam. All right, and then just a reminder of what we talked about last time. The margin of error only accounts for sampling variability. It doesn't account for any bias in the way that we do our sample. All right, so last thing, sometimes we are given a sample size, and sometimes we're trying to plan a study and figure out what sample size we can use to balance, like, the fact that we want to reduce our margin of error, but also samples are expensive, and finding people to sample can be expensive and difficult to do, so we have to balance those two goals. So we can actually use the formula for margin of error to determine what specific sample size we would need. All right, so in all of these pieces, we would be given a margin of error, and this time we are solving for n. Because this is being done before the study, we're planning it out. We don't know what p hat is because we don't actually have the data yet. So we have to guess a value of p hat to use in this formula. So we have two options. If we have like some past data or past experience with this particular subject, we might be able to use an estimate from p hat based on that. If we don't have any of that information, we're just going to use 0.5. This is the most conservative guess we could possibly come up with, and so that works as a value as well. All right, so here is our example. You can pause and read it. But basically we want a estimate to be within 3 percentage points. So that 0.03 right there, that is our margin of error. So how large of a sample do we need? Okay, so we have our margin of error formula, 95%, so my z-star is 1.96. And we're not given any information about previous p-hat, so we're just going to use 0.5. And we're going to just take this equation and solve for n. All right, so now lots of algebra, multiply by 1.96, square it, multiply by n to move it over, and then divide. Okay, and at the end we get 1067.111. All right, and so that means we're going to always round up and take an n of 10,068. Because if we did use 1067, we're under our required sample size, so we are always going to round up. All right, and that's it for 8.2.